Okay, I have a couple more problems for you to try on your own. So please try these and then resume the video and see if you were able to get the problems correct. I'll go ahead and work them out right now. So for this first hyperbola, we know that we have foci at 10, 0 and negative 10, 0. And we have asymptotes at 3/4. So, in this case, we know that our C value equals 10. And we know that our center is at 0, 0, and we have a horizontal hyperbola. So we can start with x squared minus y squared equals 1. So we do know that our slope, in this case it's not a over b, in this case our slope would be b over a. Since this is a horizontal hyperbola, we would have to go up b and over a to get to our vertice. Unfortunately, we don't know what these vertices are. The only hint that we're given is that b over a equals 3/4. Or we know that b equals 3/4 a. So what we can do is we can use our equation, c squared equals a squared plus b squared, and a little substitution to help us figure out what these missing values are. So we know that c is 10, so c squared is 100. We don't know a squared, but we know that b equals 3/4 a. So we can take that and plug it in. Don't forget the squared. So now we know that 100 equals a squared plus 9/16 a squared. And if you combine like terms, 100 equals, that a squared is really a 16/16 a squared. So that would be a 25/16 a squared. So now when we divide 100 by 25/16 or multiply by the reciprocal, we get that a squared equals 16 times 4. And when we take the square root of that, little trick, you can take the square root of 16, which is 4, and multiply it by the square root of 4, which is 2. So we find out that 8 equals a. Yay, finally we have some information. So we can go ahead and take that 8 and throw it underneath our x value, square it first, so we know that 64 is going to go underneath the x squared. But we still need to figure out what b is. But luckily we have the equation, b equals 3/4 times our a value, or 3/4 times a. So b would equal 6. And that would mean that we have a 36 underneath our y squared. Okay, for our last problem, this should be more similar to what we've learned before. The last one was a little bit tricky, so if you didn't get that one right away, no worries, now you know. Alright, so for this hyperbola, we have vertices at -2, 1 and 2, 1. Which of course means our center will be at 0, 1. And we have foci at negative 3, 1 and 3, 1. All right, so we know that we have a horizontal hyperbola, so the x squared will go first. And this time we have a center at 0, 1, so I need to put a y minus 1 squared. That'll all be set equal to 1. We know that our a value is 2, so I need a 4 underneath my x squared. And this time we're given the c value of 3. So we can use our equation c squared equals a squared plus b squared to find out what b squared equals. So since the c value is 3, we know that c squared is 9. We know that a squared is 4. And now we can tell that b squared equals 5. So we'll put a 5 underneath our y minus 1 squared term. Classifying conics we'll go over more in class, so don't worry too much about that right now. But basically, if we see a conic that has an x squared plus a y squared term, for example, 9x squared plus 16y squared plus some other things, we know that that will end up being an ellipse because we have a plus sign in between our x squared and our y squared term. There's another example where this could happen. If we had something like 10x squared plus 10y squared plus some additional terms equals 0. Notice that the two coefficients are the same. This will end up being a circle. And we'll explain more why later. If there is a subtraction sign between your x squared and y squared terms, that automatically tells us that we are working with a hyperbola. And last but not least, if we have a conic section where only one of the terms is squared, then we know that we are working with a parabola. So that is it for section 9.3.